Cool. This is my third try. The first one I didn't, the microphone was muted. Awesome. I've been talking for 8 minutes. No microphone. The second try, the microphone was unmuted, but it was clipping crazily. And then I changed the volume mid-video, OBS crashed. It's so cool. Anyways, I've been watching Kaze and Randy videos, and they seemingly upload daily, or pretty often at least. And they just talk about what they did yesterday. And I thought those videos were so cool because they are realistic. You know, they show realistic changes. They show that sometimes you just don't, you spend all day on 5 lines of code, and sometimes you actually find cool shit. There's so many games that I like following, but there are new devlogs once every 6 months, once every year, or they just stop and you don't even know if they ever stopped working on the game. So I think maybe it's cool to just do more frequent updates. And I'm working on stuff constantly, almost daily, and I never have anything to show. So I thought maybe I should try these daily update things. So I've been working on a game engine. Most parts are there that you need to make a game. The big one missing is collision detection, and I've been procrastinating that for a long time. There is a collision detection library that I wrote, and I started 3 years ago, and I kept coming back to and was never quite in a good shape to use when I wanted to use it. So I did something else, found another workaround, did some shitty version of it or whatever, and then didn't use it. And then sometimes I refactored what I need to refactor, and I think I did 3 or 4 major refactorings, and they're always so annoying. And yeah, so when integrating this into my game engine, I thought I found more stuff that needed refactoring, and I've been spending hours and hours on this. But the last missing piece, the last big refactoring was, I'll explain later, but the missing piece was a high-level API, and this is what I've worked on the last weekend. I've been making sketches on that for months also, but last weekend I started doing it, and today I just debugged it. There are a few annoying ones, but I got them all. I think. Who knows? The low-level API of this collision detection library is too low-level to be fun. You have like a collider structure, and there's a user data in there, which can be anything, and then a support function and a raycast function. The support function is something that's commonly used in geometric or in computational geometry stuff. It sort of describes convex shapes by giving you a point in that shape that's most along a certain direction, which is hard to visualize sometimes. You think you get it, but then you draw it out, and sometimes it's different. Anyways, but this is all you get to define a collider, and then you have some set transform and your support functions. You can get a bounding box, and then you have different user data for a triangle collider, for a sphere, for a convex polyhedron, and then you can run collision detection algorithms on this, like GJK, and then you can use EPA to find separating vectors to resolve these collisions. But generally, it's a lot of wrangling, a lot of creating colliders and user data flying around, and managing memory on your own. This library tries to manage as little memory by itself as possible. It's all external, except this AABB tree, which is used as a bounding volume hierarchy, because you don't just want to check one object against every other object. That's O(n) squared, and those checks are expensive anyways. So you have them all in a tree, where you can do fast queries about where stuff is, which stuff is close to other stuff, and then you can check only those other colliders that are pretty close. And you can use that tree for raycast as well. I think this tree is actually pretty cool. Like, there are some resources on this, but I think someone should make maybe this could be a cool video one day. Yeah, and this tree, I was an idiot. I made this tree so you could just insert colliders, and then later I realized for mesh colliders you need to insert triangles as well, so I needed to make it generic. And then making it generic, I had this huge problem with these queries because they returned, it's difficult to explain, but it was a mess, and I went back and forth, and I finally figured out how to do it. I managed to do it, and then I started with this high-level library. But I think you get the idea. There's a lot of, you see the methods, you feel like you almost need to understand how all of this works to use it, which defeats the point, sort of. So this is a helper library for someone that already knows how this stuff works. There's no one, I mean, it makes no sense for anyone to use this, seriously. But if you know how to use this, and I'm the only one that does, and always will be, probably, then you can make a high-level thing pretty easily. And that was the final step. And this thing will be integrated into my engine almost as is, with some nice conversions here and there. And then you just have an init and a shutdown, and if you do anything wrong, it just fucking explodes and crashes, which I like, which I think is how it should be for games at least. And you can create a convex polyhedron thing, which is everything is identified by an ID now, not by some objects and pointers and silly things. And you can create a mesh, which is not convex, it's just a soup of triangles. And then you can create colliders, a sphere, a convex polyhedron, a mesh. You can set and get user data, you can set and get the bit mask, so you can group them and transform them, get the bounding box, and you can query again. It's all in one single tree. There's no, you can just don't have to pass trees or whatever, or allocate query objects, because if you do a query, you need a stack that could fit the whole tree, which is a big allocation, and you don't want to do it on the stack itself. So that's why there are query objects here that you need to pre-allocate, and this is all silliness. It's all taken care of by this thing. Yeah, and you can just ask, give me the collisions, dude. One AB give me the collisions, and raycast, and you just do raycast, and it gives you the things that it did, which is how it should be, I think. At least this makes sense to use now. There are some tricky things, because in the low-level API, you can only collide things that are convex, and a mesh, like a level, is not convex. It's made up of things that are convex, triangles, and then it's tricky to combine those collisions. It's still tricky with a high-level API anyways. But yeah, and this high-level API, it sort of abstracts this away. Collider is just a thing. It doesn't, it's not even a thing. I don't even know how to put a real boundary around it, but it's just a thing, and you can... And if you have two convex things, they collide once, probably. But if you have a level, you can have many collisions, and this thing just gives you multiple collisions. I think you get the complication here. But anyways, I made this thing now, and it works. And I made a little example where you can walk around, and I think this is pretty neat. There are walls, you can bump into them. Wow, you can walk up slopes. And this is a bit buggy still, where you're vibrating in the corner and like in obtuse corners. But that is not simple to fix. You can jump, but it's very basic. Yeah, and you see that there are raycasts too. The green thing, I'm not sure. I mean, this is close enough. This will probably be clear in the video. Yeah, next step would be to integrate this into my engine. And then, so this example for rendering, it uses some old library that I also made a long time ago. But of course I want to use my engine. Yeah. Let's see if this is the last video I make like this, because I assume it will be. But if not, I don't know. We'll see. I think it's cool.